Okay, welcome everyone to May 4th, 2020 SIG Apps meeting. Should I say, may the 4th be with you? So today we have one item in the agenda. We are going to do a demo of an open source tool called CAPT. It's spelled like KPT. And I'll let Phil and Morten to talk about it. Phil, are you ready?
I just want an announcement real quick.
Oh, sure.
It's a follow-up from a couple weeks ago. So with the StatefulSet Volume resizing, I talked to SIG Storage. There's an implementer from SIG Storage that wants to move forward with modifications to the existing CAP, go by KK. So I'm going to work with them and try to get that implemented. And Adnan had expressed some interest in potentially contributing to that as well. So I think we have enough people around.
Cool. Phil, are you there?
Yeah, I'm here. All right, should I get started?
Yes.
All right. Yeah. Yep, that's my dog. All right. So I'll share my screen here. Host disabled attendee screen sharing. Jenna, are you able to enable screen sharing, or is there something special going on my end?
It'll be easiest to add Phil as a co-host because they changed the Zoom settings for all of the community meetings so that only hosts and co-hosts can share the screen. And that usually works the simplest and the fastest.
Okay, I add you as a co-host. And Morten.
All right, are you able to see my screen?
Yeah.
Okay, cool. So I was just going to start out with a little bit of background information and then do a demo. But before I do the demo, it's helpful to give the context of what we're trying to do and why it was designed the way it was. And one of the themes is about shifting the resource model left. The Kubernetes resource model, we often, as we talk about, it's often in the API server or in the control plane, and is built using controllers and mutating webhooks and validating webhooks and resources, right? And these are kind of the primitives that allow systems to be built on top of the resource model, where the resource model are a set of declarative APIs that have different programs which read those APIs and write to them and loosely couple a number of different APIs together. And what CAPT is doing is taking the same resource model and shifting it left. And so that means that operating on the Kubernetes resources can be done before they're applied to the cluster, before you even talk to a cluster, for instance. And some of the reasons this shift left is useful, more abstractly, you can think that the earlier you catch errors on in the system, the better, the less likely they are to go out into impacting production systems. Like an example is compile time errors versus like runtime errors. If it's possible to catch an error at compile time, that would be better than waiting until it's actually been pushed and then catching the error then. So the more we can shift the work left, the more opportunity we have to catch errors before they go out. And one thing I'd really like folks at watching this to kind of take note of is the architecture. I think this is probably the most interesting topic of discussion rather than what individual feature happens to exist today, because KEPT is still new and it's going to develop new features and probably evolve in different ways. But this architecture is really the foundation of what we're trying to do. And so the first, I have 3 bullet points here that I think capture a lot of it. The first is the output of KEPT should be Kubernetes resources and maybe open API, right? And so this follows the Kubernetes resource model where controllers, for instance, are writing to resources in the API server. And this basically means like you need to be able to control apply whatever KEPT outputs, or it should follow roughly like what the Kubernetes examples on GitHub show. It should look like these things. And it can write these things to different locations, right? So it can write resources to files, to standard out, to API endpoints. These are all valid locations. What's important is that it's writing resources that the Kubernetes API server like could conceptually understand, right? Maybe one is a CRD isn't installed for one, so it doesn't mean they need to be the native APIs, but they look and feel like Kubernetes resources. And I think most tools kind of follow this eventually at the end, right? Like since this is the native speak of the Kubernetes API server, eventually if you're going to create a resource, it's going to have to output something that looks like a resource. The next one, not all tools do. And this is what the input looks like. And this is that the primary input must also be Kubernetes resources. This is the input and the output are symmetric. It may read open API. In addition to Kubernetes resources, this follows the conventions of what for instance, the tools do. Kube control reads open API from the API server, and the resources also follows what how the controllers tend to work, where the controllers are also reading resources from the API server. And so, this is kind of the gut check here is it kube control gettable? Like the inputs, are there something you could get from kube control get, for instance? Do they look and parse like that? Or are they something that you get from GitHub Kubernetes examples? And are the Kubernetes examples like functional inputs to KEPT? The sources it can read from files, standard in, API endpoints, Git. So again, where they happen to read the resources from is less important. What's more important is it's reading resources. And then the third point, I think, is especially noteworthy because it follows what the controllers do, but a shift from the way traditional tools have operated, right? Which is that it needs to be able to read what it is written and perform like level-driven updates, sort of like a reconciliation, rather than just regenerating everything from scratch. So this is the microservices architecture, right, where you have different modular components reading and writing data from some backend or from the API server or that sort of thing, and interacting by reading what each other have written and reading what they've written in the past, rather than sort of a model where it's having a central piece that generates a bunch of stuff from scratch on its own. And so what do we get from shifting the model left, right? So it can run in CI/CD workflows. You can script configuration changes that can then be reviewed through PR checks and rolled back through Git. You can do different development workflows around like IDE integration and validation. So IDEs already have some validation based on the open API, but you can imagine what would normally be in a validating webhook. Wouldn't it be great if your IDEs could just capture that same validation and apply it right in the IDE as you're developing, rather than having to actually try and push something to production to catch that validating webhook's not gonna work. And one advantage of the shift left approach is that the scope of what it can validate is greater, because it can validate holistically all the resources that are going to be applied in the bundle, whereas validating webhooks only work on a single resource at a time. So trying to catch something in validation like this deployment plus this service plus this config map much look like this collectively is going to be harder to do with the validating webhook than it would be in shift left. And then finally on operations, the shift left provides a nice solution for doing cross-cutting transformations, injecting init containers, these sorts of things. This can also be done with mutating webhooks. A lot of the work in kept can be done on the server side, right? That is by design, that's the architecture. But there are reasons that maybe you want to do it on client side sometimes, or at least shift left in CI/CD, or before you're trying to push something to production, right? And you can visualize the changes, for instance, in a diff with shift left, and you can have them reviewed and rolled back with pretty clear workflows. Whereas if you're doing a mutating webhook that operates on a pod to inject an init container, and that creates a problem, how do you roll that back, right? It's more difficult. And so really, kept is providing low-level configuration machinery, or that's its focus initially, right? And so this is packaging, Git plus YAML. How do we do that low-level piece of not copying and pasting the Kubernetes example, right? And you can clone that thing, but there's some challenges. Like Git is not designed oriented around resources. If you want to do an update, for instance, it's going to do file-based updates as opposed to resource-based updates and these sorts of things. Another low-level piece it does is static modification of configuration. So how can we define things like set image or scale or these sorts of things, which read and write configuration files, but basically statically, like I know how to set this value because it lives at this particular location or that sort of thing. And then finally, dynamic modification of configuration, right? So these are things where it's not simply a matter of go find this field and set its value to this, so go find these different fields and set their values based on these inputs. But it becomes more like, this is more the controller-based approach where it's like, okay, look at the holistic system and then what the desired state is based on what the user's specifying, and then figure out how to make it look like you want it to, right? Like the program thinks it should. And then finally, there's an actuation piece, which is reading and writing from the API server. These are the extensions, or they're like apply and status and these sorts of things, which we're pretty familiar with. All right, so now I'll give a quick demo. So I'm going to give a quick demo of kept. I'm in this kind of empty directory here. I'm going to use demo magic to kind of run the commands for me so I can talk as it types the commands for me. So the first thing it's going to do is fetch a package from Git. And so this is saying, go find in the subdirectory from a little Git repo I wrote for this example to pull down the configuration, right? And so at this particular version. And then typically in a workflow, we want to go ahead and add this to Git right away. And that'll make the diffs easier. I can use git diff to kind of show you the changes as we modify this thing. And so kept has some commands for just viewing package configuration. Here happens to be one of them that allows you to kind of quickly at a glance see what have I fetched, right? But if we look at what is actually fetched over here, you can see that it's basically a YAML configuration file. And so following that, it has to apply to a cluster thing. Like we can just kubectl apply this thing. Kept has its own apply utilities, which allow for some nice functionality. But right now I'm going to use kubectl just to demonstrate the philosophy again. And you can see that there is this etcd thing running. And so now maybe you want to like modify this thing locally. And so this is not something you necessarily have to do, but one may want to modify their package that they pulled down and add some stuff, right? And this is demonstrating that, again, it has to be able to read what it is written and do level-based transformations rather than like regenerating from scratch. So as we modify this thing, it should be able to keep those things because it's reading and updating. And so what we're going to do here is we're going to go ahead and update this package from upstream to a new version. And this should go ahead and keep the annotation I added while pulling in upstream updates because it's doing a merge, right? And so you can see in here that it's just changed this to a 5 from a 4. You can see that change here as well. So that's what was changed in the update. You can also see that it's kept that annotation bar, again, reading what it is written and doing updates to it. Going ahead and VIing into these YAML files is not always the best way of, not always the way people want to edit stuff. People there's different reasons you may want to just have quick commands to go and change these things. It allows tools to do kind of the heavy lifting for humans so that it's less likely humans are going to make mistakes. And you can see what I've done here is just added run the set command. So these are this notion of setters. These are the static transformations I was talking about, where it's possible to define sort of static ways that the configuration may be manipulated. In this case, we set the replicas, and then maybe we added some metadata about why we set it that way and who set it. And so now you can see when you list these setters that replicas have been set from 1 to 3, and you can see I set it and kind of why I set it that way, and that changed one field. There's also a name field which will change 10 different fields if you set that one. And so you can see here what that's done is it's gone and it's just updated the YAML file. So again, going back to that philosophy of it reads YAML, it writes YAML, reads what is written previously. And so this is loosely coupled with the packaging piece. Like the packaging piece reads and writes YAMLs, the setters piece reads and writes YAMLs. They don't really need to know about each other or how each other operate, allowing better interoperability. And so this case has just gone ahead and updated that. And I'll talk a little bit about this. This open API piece actually is how the setters are performed. The inputs are open API, the outputs are open API. And so we're using open API to describe metadata about the configuration, just like kind of Kubernetes uses open API from the API server to describe metadata about the configuration. So we're going to go ahead and apply this thing with our changes, and we're going to see that actually it's not working. There's these errors, right? And that's because the way I've designed this is that while it changed the replicas, just changing the replicas isn't enough, right? In this case, doing a pure static transformation, which would work great for certain things like image and replicas, maybe for deployment and other things. In this particular case, for the stateful set, it's saying you can't just change the replicas because the other replicas now are not configured correctly with the right set of initial cluster configuration. And so we're going to fix this by adding dynamic configuration. So I'm going to go ahead and pull in an upstream update. And this update is going to add a couple things. It's going to add this function declaration. And there's different function runtimes, and this one happens to be written in Starlark, which is kind of a experimental runtime that hasn't really been supported yet, but I think demonstrates very well the architecture that we're trying to show here, which is because it allows you to quickly perform a dynamic sort of scriptable transformation without executing arbitrary code on your machine. There's other runtimes that allow this too, and containers are actually the primary runtime we're supporting, but this one happened to be a little bit easier for the purposes of demonstration. And so it's updated this configuration to say, hey, this thing now has this function, which is a dynamic piece of code, which should perform transformations, and it's done through kind of this Starlark script here. Again, this is the Starlark piece is experimental. and really great for demonstration, but the containers are the more mature of the two. And so this time we're going to set the replicas to 2. We're going to see something different this time. The replicas have been changed, but also this value of the initial cluster has also been changed. You see, and so that initial cluster is, instead of just being statically defined as the first pod, it now includes all of the different pods that we expect based on the replicas. So I'm going to delete that pod. For some reason it was having trouble restarting, but now you can see that it's running successfully here. But now that we changed that, and so I'll show you quickly what the reconcile function looks like. It's this small snippet of code, but what it does is it takes in a list of items, and this schema is well defined, or the input output is well defined for what functions look like in this case, and it takes in the items this way, and then so it pulls out those different items and then goes and finds the matching stateful set based on the name of kind of what was annotated with the function and these things. And then it goes, pulls out the replicas and the service name and the port, and then figures out what the list of pods are that are going to be part of the initial cluster based on that. And then it goes and it sets here on that environment variable that list of pods as the initial state, right? And so it's gone and modified that particular resource in the items, and then kept itself will then write that back out. And so this is automatically triggered anytime set is run, right? So by virtue of setting this to 2, it runs this function, and that function's job is just to make sure that all the configuration looks correct based on its current set of values. And then I can show you, so the open API for the setters, this is kind of how the setters are defined. It's done through these open API definitions, which describe, like, here's the name of here's a name of a setter called replicas, here's who it was set by, and here's its current value. And so going back to that CD YAML file, this is just an open API reference. And so these resolve using standard open API libraries. There's nothing kept specific about this reference or resolution. The only things that are special are that kept looks for open API as comments. So as it parses YAML files, it looks, hey, is there an open API definition that comes as a comment on this particular field? And then it also parses additional open API definitions from the KEP file. And so using those two things together, you can augment the open API provided from Kubernetes with your own extensions, and then you can customize the individual objects open API to be something more than just like the generic open API for that type, but you could say for this particular object, even that these are how these particular fields look, which opens the door for, in the future, doing things such as saying this particular maybe image should have this regular expression, and putting restrictions on certain fields for particular objects while still allowing end users to do modifications to them and customizations. Okay, that's my demo. I guess, is Morten up next? Janet, should we do questions on that first, or should we do Morten's demo?
So I think Morten has some demo. Do you want someone to take questions first, or do you want?
Morten, what do you want to do?
I can just run through it. It's just a smaller part of KEP than what Phil went through, so it shouldn't take too long.
Great.
Okay,
Let's do
run
that.
and then we'll have questions.
Yeah. Let's see. Share my screen here. Can you see my screen? Cool.
Yeah.
So
To increase the
I'm just
font,
gonna how? What do you mean?
like the text is just small. That's all. It's kind of hard to read.
I think I'll have to do it like this because I'm going to demo something which might might if I change the font size, it might not work too well yet since it's still early. So it's going to show is the kept live functionality, and this is for applying kept packages to a cluster. But kept packages really is just Kubernetes resources. So just like Phil demoed kept with using kube control, I'll just demo kept live with regular resources. So I just have a set of 5 different resources here, and I want to apply those to a cluster. And kept live adds a couple of things on top of what you get from kube control. So it has pruning, which is slightly different than how pruning is done in kube control. It adds ordering of resources, so it makes sure that if there's namespaces, it apply them before things going into namespaces. And it also handles resource status, so you can apply something and wait for it to reconcile. So first thing we need to do is, because the way pruning works, we create inventory objects as part of apply. And to do that, we need to know where we want to put those inventory objects and also generate an ID. So first thing we need to do is just do kept live init, and now create an inventory template, which is just a config map. I can show it here. So it just contains, the important thing is namespace and the annotation at the bottom. Now I can do then is I can do a preview of what will happen if I apply this. So I can just do kept live preview. I'll show that it'll create pod, disruption budget, a cron job, and yeah, you can see the inventory object on the top. And then I can apply this. And then I wanted to wait for reconcile. This means that it'll wait for resources to reconcile before it blocks until all the resources have been reconciled, and then it'll print status as it goes. You can see it created them first, and now it prints changes. You can see the deployment has all the 8 replicates already. I think we're waiting for the last stateful set. So, and there everything is rolled out. So now everything is not only applied, but it also, we know that it reconciled. We can also get another view of this, and this is why this is new. It doesn't handle soft wraps properly, so that's why I needed a larger screen. So this shows all the resources. It shows the resources that are generated and the status, conditions, and some information about all of them. What we can do is now, if we want to update something, let's say we want to change the stateful set here. Let's say we want to increase the number of replicas to 4. And then we want to update the version. What I can do now, I can just run apply again. And you can see here how the stateful set now will start creating pods. And then we'll see as it cycles through, first add 2, we'll see it adds number 3, and then it'll go back and add or delete and recreate the earlier ones. You can see here that the way stateful set works, it'll create the new ones and it'll go through each of the previous ones and terminate them and then recreate in depending on the ordinal of the pod. So this view is partly inspired by the kubectl tree command. Okay, so there's also a timeout. So now this didn't, I forgot to set the timeout to longer than 60 seconds, but the reconcile was still happening in the background. What we can do now is we can just delete the stateful set, and then we can do a preview again. And then we can see here that when we run apply next time, we expect the stateful set to be pruned, the service, and also the existing inventory object, as it will create a new one. And if you do apply again, we'll see that the stateful set is no longer there. And this will be deleted in the background. We're working on functionality to wait while pruning happens too. And finally, what is possible, you can also do get-live preview. If you do destroy, then the destroy command is a separate command, which will take all the resources and just in this package and delete it from the cluster. So I can just do a preview. And obviously, if I do destroy, it'll just delete all of it. Yeah, I think that's it.
Any questions?
Yeah. So with the functions that you set that are able to update it, you use open API specification to specify a call into a particular runtime, if I understand correctly?
Sorry, can you say that one more time? The audio went out halfway through what you were saying and then came back in.
So, okay, with the functions that you use to do the updates, right? Like the callbacks that get called on set, for instance, those are specified via open API, correct?
There's a couple ways of, no, the functions are not specified via open API.
But the reference to call the function is open API, right? Or no?
No, so there's two ways of, there's a couple ways of running the functions, and there's layers in the functions. So at the layer you're talking about is effectively how are they orchestrated, right? Like what causes them to be invoked. And there's a number of ways of specifying them to be orchestrated. The one I demonstrated is through an annotation on a resource that says, that effectively describes how to invoke the function, like how to set up the runtime, right? And so for containers, that would be like, should you enable the network, or like by default, the network would be disabled so that it's relatively safe to run and it won't send your configs to some malicious endpoint or something like that. But you can say, oh, we need network to be enabled, and then that's possible to do, or those sorts of things. Those can be set on if those are set on any resource, then it will cause the function to be read with the resource that contains the annotation to be provided in a special field in the input called function config. And so you can design a system to look kind of like a controller, right? Where you could create, for instance, a new client-side CRD, if you will, is the way a lot of people have described it, right? Where you have some abstraction type, and then you can put the annotation on there, and then that would cause KEP to go invoke the function providing that sort of abstraction type as input, just like a controller CRD model would work. And then the rest of the resources that are scoped to it, those being in the same directory or subdirectories, would be provided as items, and then the function would go and look at that function config, and then look at the resources, and then make sure that the whole system looked correct. What I demonstrated is a little bit different model than that. So instead of doing an abstraction, right, where it's like a new type, I demonstrated a function on like the actual resource itself. And then the function's job is to validate that individual resource. But it's also possible to run functions like imperatively on the command line. You can give it like a dash dash image. You can say kept. So I also demonstrated an implicit run where the function is run after setting just to normalize everything. There's more of an explicit run where you can say kept function or kept fn run on a directory, and then it will traverse all the configurations and then run all the functions. You can also do an imperative mode where you can say kept fn run and then say dash dash image, and then it will run the function from that image explicitly, passing in all the configuration into it.
If I have to mutate, so let's say I have one parameter that would cause effects across multiple resources. Would I have like one function that gets invoked for multiple resources in order to update those resources in sequence, or would I have like you said, like a client-side CRD and then treat those resources as an artifact that's generated?
So you have one function that updates multiple resources. Like, can you maybe, what's a concrete example, maybe, if you happen to have one in mind?
Let's say I was dealing with like a typical stateless serving workload. I have like a deployment, I have service, I have pod disruption budget, I've got a horizontal pod autoscaler, so forth and so on. And like I want to make sure that I want to make sure naming is consistent across all of the resources, for instance. So when I update my app name, I want to update all of that consistently. Or I want to modify labeling across all of them and ensure that the selectors conform to select the right artifacts.
Mm-hmm. Yeah, yeah.
So how is that managed?
So like, how would you apply that, right? Is that the question?
Yeah, what would be the correct way to manage it? Would it be like having specific functions for each individual resource that are triggered off of the same input, or have one function that operates across resources? Is
no,
that
so
possible?
The offhand, starting with like the simplest approach that introduces the least amount of change to your existing system, and then maybe only shifting into divergent stuff when the benefit is clear. I'd start out with, okay, what's closest to the system you're running today? Well, if you have some CI/CD system already set up, I'd like maybe create a GitHub check or something like that, or whatever your CI/CD system does as part of a PR, and I'd run it potentially imperatively. That would be like the simplest starting point, right? And so you'd say kept fn run and then dash dash image, and then give it the container on the directory, and then that container would be invoked with all the stuff, and maybe give it some arguments into the function that configure it. If you give it command line arguments, it will automatically generate a function config based on those arguments, and pass that in. And so then from that starting point, then you get a cross-cutting view of, okay, validate this whole package that's integrated into your CI/CD system.
Okay.
And then so then from there, maybe you add 2 or 3 of these things, right? And then now maybe their configuration is starting to be more complicated, where it's not just like, make sure all this stuff looks good and here's 1 or 2 key values, but it has a spec with nested fields and list items, right? That's where you start to look like, it starts to look more like an abstraction type. And instead of people just running on this in the CI/CD system where it's embedded into that script, you want it to be run as part of your make process whenever someone runs locally. And then that's the point where maybe you want to start looking into, do we want a declarative approach? Or if you want scoping of different functions to different subdirectories, like you have a package of 20 resources with different subdirectories, and you want this function run against one subdirectory and that function run against a different subdirectory, and then you want to run one command that does all of them. Like, these are, I say, more sophisticated techniques and needs where then it makes sense to do them declaratively. But if you just want to say, here's a collection of resources, please error out instead of allowing a PR to be merged if they don't look good, just running them imperatively, I don't think there's anything wrong with, certainly.
Okay.
But that's probably, it depends on probably the rest of your CID's process too, right? Like, so going with the principle of it's maybe best if it kind of fits into what processes you already have. Like, if you have a CI/CD system that runs a bunch of checks, like adding that check imperatively there if everyone's going to understand it, that makes sense, right? If you don't have that system in place, then maybe you don't want to set it up and you just do it as what I do in that case, right, is I create a new configuration file for your abstract type maybe, and then at kind of the root or above the root, add the annotation. The annotation would describe the container or Starlark script or whatever runtime you happen to be using. Then you run kept function run on that directory, and then it would invoke that thing. If that fits more in your better in your workflow, then that makes sense too.
Okay. I have another question, but I don't want to eat up the entire time if anyone else has questions.
No, sounds like go for it.
How do I do, so if I want to use this, so let's say I have a package and then the package needs to be deployed across multiple environments, right? Like my primary need for customization is to specialize a package to deploy it in different EMDs. How does that work in this model?
I'd say this model still, so I guess going back to if you have a solution now you like let's say you're using Kustomize today to do it, right? And you had a different customization for each environment, right? Then it would work pretty much, it would be a value add on top of what you're doing today, right? So you would write your package as, you know, a collection of, it would contain the different customization files, right? And so your package maybe now includes all the environments. I guess I'll go through two scenarios. So say you're at the deployment piece. So then maybe that's your kept package. And so you run customize build or kubectl apply -k or whatever it is against each of those environments. What you might do now is, like, what do you do on top of that? Well, maybe right before you apply to an environment, you need to set the manifest of the image, right, that you just built. And so before, maybe you had if you had a process where you set it in, the SHA of the image into the image tag, right? Now you'd maybe create a setter for that, right? And so now programmatically from, you know, your deployment pipeline, you can run set image and then run apply after that would be one way of integrating these capabilities to maybe solve a particular need. Another one would be you could hopefully can't actually remember if yeah, there's a way to write up the function so that you can like do customize build and then pipe it into a function, for instance. So maybe right before doing kubectl apply, you'd customize build the environment, pipe it into a function, make sure that that exits successfully, and then apply after that. What are the problems you're trying to solve?
I was trying to understand how it fit in with overlay customization for multiple, if I want to use overlay-based customization for multiple environments. And it sounds like primarily it's a packaging system that's a value add on top of that that's compatible with overlay customization, but doesn't mandate that particular approach.
Absolutely. So maybe I'll say two things of how maybe this fits in with Kustomize. The first is, even if you're using Kustomize to use bases and such, there's still a bootstrapping problem of, well, how do I get that initial customization.yaml, right? That says which bases I'm using, right? Or what the different, you know, common annotations and common labels are, right? And so you probably end up copying and pasting that from some location, right, to get your initial state. And then now that's kind of orphaned from wherever it was copied and pasted from. And so if you want to update the version of Kustomize, for instance, and that means some new feature was enabled and you want to add that to the customization file in the example, like how do you get the latest version of the example, right? So making the customization YAML itself a package and then kept getting that and then just doing your normal workflow does solves a couple of those problems for you. The second is, I'd say, blueprint customization. So there's the environment customization, which I think what we're just talking about. And then there's maybe a blueprint customization, which is, okay, I want to just like 3 Java backends, right? And you can use customize to do that using different bases and creating different graphs. And some people really enjoy that model and they like it, and they totally get it. In which case, keep going that route, right? Or that it's not wrong to do it that way. But the one trade-off there is you end up with kind of a large graph, right? And I've seen some very deep customized graphs, and then folks, you're kind of limited what can be done within the customized framework. A customized framework is very flexible, so it's not like there's a lot of limitations there, but you are working within this graph now. And so maybe if you're like saying for whatever reason you don't like that approach, and you just want like, hey, I want 3 copies of the backend, and then I want to manually customize those things instead of using patches, and I just want to pull them down from my example. And so what you would otherwise do is copy and paste the Java backend YAML 3 different times, and now those are your customized bases, right? And that would be kind of your blueprint approach. Well, KEP now allows you to pull down those different Java backends into different local packages. And so instead of having a shared base between a shared Java base that you try and create this customized diamond-shaped graph with, you no longer, you have a different sort of graph where each of those is a completely independent node and there's no shared base between them through the customized graph. But when you want to pull down updates to them, you use KEP to kind of do that resource-based merged model of pulling in updates from wherever they originally came from. And I guess I'd say the way I've described customize and kept to folks, because some folks have asked like, well, should I use customize or kept for this? There seems to be overlap in what they're capable of doing or the problems they're capable of solving. And the metaphor I've held in my mind is kind of like, in a programming language, you have both while loops and functions, right? And technically you can write a program without functions and just use like ifs and while loops, right? And technically you can write like programs without while loops if you get like some crazy recursion, right, with functions, right? And so while both functions and while loops have overlap, and when you have a particular problem, you may say, should I solve this recursively with functions, or should I solve this with a while loop and a stack, right, on any given problem? And the answer is, it depends on the problem and what your programming style is and what happens to make sense there. Yes, there's overlap between them. Yes, it makes sense to have both of them because they provide slightly different ways of solving kind of the same problems that can be used together.
So for the stateless serving workload example, I imagine that you might have like a blueprint called service or microservice, which contains all of the resources that you would generally have to start with. You could use that blueprint to generate YAML that instantiates a specific service, give it an application name, all of that stuff. And then you could use customize for last mile customization as you deploy that YAML across different environments. Like that would be the pretty much, yeah, okay.
Yep, that's the model we're considering. And then you can even throw in functions. Like we're gonna have to get more opinionated here. I think what we're gonna have to do is build more like very opinionated workflows. And maybe there's probably gonna be 3 or 4 different patterns of like, if this is how your organization does something, here's how you do it. But you can even use functions on top of that, right? So you could use a function with an abstraction that generates the config, and that's your package. Your package could just be the raw YAML for the stateful or stateless service, and then that's your package, and you pull that down and modify it in place rather than having an abstraction. In either one of those cases, you can use either the output of the function or the raw base as customized bases, and then do variant customization from there. Does what I just said make sense?
To me, yeah. Any other questions?
I have a question about how CapLive prune is different from the one in kube control.
So the prune in kept is based on creating an inventory every time you apply, and diff inventories against the next sort of set of resources. The one in kube control is based on labels, I think. So it's a slightly different approach.
Any other questions? I think we have 4 minutes left. If we don't have other questions or topic, we can end the meeting now. Thanks everyone for joining us.
Yeah, awesome demo, Phil and Morten. Thank you.
Thank you.
Thanks for having us.
Thanks a lot.
Bye.